I was watching a video and someone asked a question about it. The video basically talked about felling a large oak tree for use for lumber. They said it was different cutting for lumber than just normal tree removals. And I do agree with that. But what I found in the video, they started the cutting process, and more or less in that cutting process, they talked about they had used a bore technique or plunge cut technique on trees before, but in this case, they were not going to use it because it was going to be used for lumber. Well, the tree was pretty good diameter, looked like from the video had a good bit of forward lean on it, and more or less he said too that a lot of times he'd use a open face, but in this case a little bit different cut because it was going to be used for lumber. And then the cutting process started, and the face notch that was taken out was probably around 50 to 60 degrees, so a common notch. And then the back cut was started. It went on a good ways in the video, and you know, as you start to think about the back cut with a forward-leaning tree, as the tree starts to move, then more or less it's going to start to pull any fiber that's still attached. So I watched, and even wedges were put into the tree, the back of the tree, and hammered in. And you know, when people don't really understand a forward-leaning tree, there's no reason for wedging, because the weight, gravity is going to take that tree towards its lean. What was holding the tree in that case, and I think the reason why they thought they needed wedges, was simply because the tree wasn't moving yet. Well, why the tree wasn't moving was simply the fiber that was still holding. In other words, it wasn't set up with a hinge. It was set up with still probably a third of the tree still holding as far as the fiber that was being cut. When you start to think through the process, there were two things that were evident there. The operator didn't really understand that forward lean was going to go forward. The other thing is that when the tree was down, there were splits and pulls and cracks. And that was the reason, or that happened because of simply the face notch was closing at a point that the tree was not totally to the ground or the tree bounced. And the other reason was because the hinge was way too thick during the movement of the tree. So when that happens, you're going to get pulled fiber. The hinge breaks from the back to the front. Understanding that the hinge breaks from the back to the front, it has to be thin enough to allow those fibers to bend over and not pull. You see, when the hinge is too thick, it starts to separate at the back, and then if it's too far back, the fibers tend to pull out vertically instead of bending over and breaking. And that's a key factor to understand. When the face notch closes, that's going to cause the fiber to actually pull vertically out. And so again, you have pulls and splits instead of the hinge working as it should, breaking short fiber from the back of the hinge to the face notch itself. But let's go back to the issues that really started it, and that was the lean of the tree. You see, If you understand how the lean works, then you can basically be able to use the proper cuts to control it. This was the toughest part for me to learn when I was being taught about felling trees, to put together the plan. And the plan we always worked with was, number one, looking for any hazards and issues there as far as limbs that could come down, vines that might be pulling, those types of things, and then obstructions. You know, so many times we think about, oh, that tree's leaning over there, so that's the way it needs to go. If there's an obstruction there, a fence, a power line, a house, you know, bad terrain, all of those things, then more or less it can't go that position. So you have to be able to take lean information to put it in the right spot, to put it in a spot that's long enough and wide enough to be able to accept the tree. So as we start to think through, first is looking at the surroundings of safety, you know, hazards and obstacles. Second is then to look at leans, and leans need to be observed in two positions. The first position is in the direction that you want the tree to go, and it's weighted objective side to side. The second lean that we need to look at is the lean forward to back. Forward to back is basically, is it leaning towards the location you want it to go, or is it leaning away from it? And so that's your determining factor. Both of those actually are planned in relationship to the hinge material that you plan to control that tree with. Third thing then, once you understand the leans, you're observing a good side, bad side from the side leans potential. You're observing whether the tree is going to fall under gravity and weight in its own position because of forward lean, or is the tree leaning back and we have to pull or push or lift the tree to that location you desire for it to go. Then is it open enough, and can I get away from this moving tree far enough to prevent being part of a struck by situation? And so that's determining your escape route. Fourth is the hinge itself, and that's looking to see, number one, is it going to be thick enough to be able to support the weight of the tree? And that means, is it going to start to tear or pull fiber, or is it going to basically bend as it starts to move in the direction you want it to go? And then the other is side to side. It supports the length of the hinge, supports the side weight of the tree. And so both of them keep it attached, maintaining control of the side weight as well as maintaining the hinge breaking back to front till the tree gets to the position it needs to be. And then the last, what you're using all of this 4 steps of information for, is to determine what type of back cut that I need to place. Back cut could be a couple different things. If you have a bar that's not quite the diameter of the tree, you can be able to take away material, say half of the tree from the bad side and half of the tree from the good side. That might give you the opportunity to not have to chase the tree so much and have situations where fiber can split or pull. Another one might be that you have a small enough diameter tree to where you can just simply cut from the back up to your proposed hinge material thickness without any movement of the tree. But if you have a large tree with heavier lean, or a smaller tree with heavier lean, if you can't outcut the movement, you're going to have fiber pull, or you're going to have a situation you end up with something splitting, or possibly loss of control. The other thing that you can use is a plunge cut or bore cut. The hinge can be set up and then the tree released from the back. That means that you don't have to chase the tree. Your hinge is already set. You're not going to have a situation where it pulls or ends up with damage. That gives you the opportunity to maintain that fall of the tree and still maintain the quality and no stressed fiber that you need for putting that tree into lumber. The video that I watched ended up with the tree went the right direction, But as it started to go, fiber was thicker in the middle than on one side. It wasn't equal all the way across. It ended up with long fiber pulls coming off of the back side of the hinge, as well as long fiber pulls coming out of the middle of the log. So basically too, at the hinge that was too thick, it started to separate, so the log actually split up the sides of the log. Any resistance, too thick of fiber, face notch closes, or possibly the direction's not correct, and you end up with the tree hitting another tree or catching a larger limb and twisting. That's what causes the fiber pull. And if that fiber pulls or separates, then you have lumber that as it goes through the mill is not going to be worth as much. And especially when some of the best material that you have is closer to the ground, and when you start pulling that fiber and you have to cut a 2 or 3 foot section off of the log, you've lost a lot of merchantable wood fiber, as well as a loss you're looking at logging it or lumbering it. So all of the same situations happen as we fell a tree. It all comes down to that 5-point plan. We look to see, why does this happen? Why does that happen? We're not picking technique to be able to say, oh, that didn't work or this didn't work. It probably didn't work because of 1 or 2 reasons. First of all, the plan wasn't complete. The operator didn't understand the planning process, or basically the operator didn't follow the plan and ended up with damage to the tree or properties, and possibly also safety. So we look here and we think about, where is this tree leaning? And so pretty good size red oak tree, pretty good size canopy. And so we start evaluating our planning process, the 5 steps. First thing we're looking for is it leaning into an opening that's long enough and wide enough to be able to place the tree? And you can look here in front. I think we've got some obstacles that are going to create some issue. We could also height measure this tree to figure out, will it reach a certain length? Is there a fence? Is there a house? Is there a power line? Is it another tree that's going to be damaged? And so we start looking at that information. In this case here, if I look at the leans and I start to consider the options, that's where I end up having to change direction here some. If I can't change that direction and be sure that it's going to go where I need it to go, then basically this tree would have to be taken down from the top. Let's look at here. If I think through the process, if I look at the direction of the tree, and you can see here from this vantage point, it's a fairly straight tree side to side, taking the farthest limbs of the canopies to the left, farthest limbs to the right. And so there's not a whole lot of side lean in the direction of the tree. But here we have another sweet gum tree out in front. The tree is tall. We've got some possibility of hitting a house and a fence. So more or less we have to look at our options. So right now, side to side is pretty straight to that position. If I had the opening with no obstructions, no safety or hazard issues, the tree could go that way very easily, because now looking at 90 degrees to that position, about 10 to 12 foot of forward lean on this tree. What does that mean? Well, side to side is the toughest for us to be able to control. You see, side to side, the hinge is the weakest. Forward to back, it's the strongest. So as we start to think about, we move around that tree, there's issues of hazards. I see hanging limbs, I see dead limbs. but more or less very little side weight there. So I can probably control it with the length of the hinge on this diameter, which this tree is probably close to 26, 28 inches DBH. And then we start to think about forward to back. Well, I'm going to put a face notch in this tree, and I'm going to establish the front line of my hinge. And if my weight is not bad side to side, the length of the hinge should be good, but how thick does it need to be? We use a rule of thumb of about 10% of the diameter in thickness of the hinge and about 80% of the diameter in length of the hinge. So if we've got a 26-inch diameter DBH, then more or less we're looking at about a 2.5-inch hinge that we need to try to manufacture on this tree to keep the tree controlled and to reduce the chances of splitting and pulling. At that point, we have a good escape area, we have ability of good fiber there in that hinge, and so now how are we going to back cut this tree and then where we're going to escape to? Escape-wise, the tree's got so much forward weight, all we need to do is go away at a 45 degree away from the direction of fall position as fast as possible, 15 to 20 feet. We do have some restrictions back here with the fence line, but we're still pretty far back from that particular tree as it would hit the ground or start to move. We can't outcut the movement of this tree before fiber starts to pull or the tree tries to split. So we might cut half and half to reduce what we're chasing. In most cases, people would say, well, I need a 32, 36 inch bar to cut this tree. Well, that would be in one cut, but you probably still, with that chainsaw, could not outcut the movement before fiber is going to start to pull. So if you were to take that bar and use portions of it, or a smaller bar and cut half of the tree, doing the bad side first, good side second, then more or less that would give you the ability to probably chase the movement of this tree. So you would set up your 2.5-inch hinge on the bad side, say halfway into the tree, and then you would take and cut the good side of the tree up to the 2.5, and you could probably cut quickly, but you would probably be able to remedy the situation of chasing the tree and having any splits. The other one that you could use very simply on this tree to keep any pulls from taking place is a plunge or bore cut. With the long bar, I could go all the way through from the good side. With a shorter bar, I could cut a half or whatever I could reach from the bad side of the tree. And really all I've got to cut from the bad side is what I can't reach from the good side. And so in that portion, I could use on this tree a 16 to 18 inch bar. Cut half of it from the bad side, set up my 2.5-inch hinge, bore through on the good side, set up my 2.5-inch hinge, and cut backwards to the back of the tree, and more or less release that tree with a strap, we call it, in the back, and the tree would then move. And the hinge still working correctly, and probably even better, because that keeps that fiber from pulling and busting or splitting and losing control. And it also keeps anything from happening as far as fiber pulling from the back of the hinge that's too thick, too long. The only other determining factor that could be an issue would be the situation of the face notch not being open enough. In this case here, probably a 45 degree notch would be open enough because you got so much forward lean. But 70 degrees or more would allow that tree to go all the way down before you would end up with the face notch closing and any pulling fiber. Now, one thing that I can tell you on this tree, because of the canopy and the long limbs on the leaning side, when this tree hits the ground, you're going to have pull and twist. And that's going to possibly cause some fibers to split and pull. That's the reason why no more than 10% of the diameter, and that would give you the ability for that hinge to also, as it hit the ground, be able to shear and not pull fiber or split the trunk. And so that tree's definitely going to flip to one side or the other. That's the thought process as we start to look at that. And so it's important to have that plan clear in our head and be able to execute it correctly. People often look at the trunk of the tree to determine where the tree leans. And really you need to take a look at the entire canopy of the tree, because if you take the center of that canopy in relationship to the balance point, which is your hinge, then that's your determining factor in lean of the tree. It still has to be broken into side to side, forward to back. Now, in this case here, we've got a whole situation again of most of the limbs growing in a direction forward in this case. And so we take a look at this to see, where our balance point is going to be in relation. If we're going to fell it towards the camera position now, we would have probably somewhere around 8 to 10 feet of side lean to this position. It would have to the right probably about 8 to 10 feet of forward direction, if that's where we were going, parallel to the fence down there. And so here, if we take a look, now this is pretty much directly in line with that heavy lean that we saw just a few minutes ago. And so in this point, we have no side lean at all. We look at where the trunk is, and then we look at the total width of the canopy. We're almost straight in line here. So side lean is virtually zero. Trunk lean, virtually zero side to side, but we would have 8 to 10 feet of forward lean towards the camera position. And that's our side lean, forward lean information on this particular tree. Diameter on this tree, and in that case we would put our face notch back in until we have somewhere that would be about 13-inch in length. Whatever we do, usually we have some type of an idea of a plan. Maybe it's something we haven't done a lot of before, and our plan isn't, I guess you'd say, very well educated. But then there's also the situation to where we have something that didn't go exactly right. We start off with a good plan, but then if something doesn't go right, it's kind of like, oh, well, nobody's hurt, let's get it cleaned up, we'll go from there. But if we really have a plan to begin with, and we come back and reevaluate what worked, what didn't, then we're able to really get better at what we do. It's sad, I think, sometimes I see people haven't had the opportunity to be exposed to, first of all, the planning process, and then the second is to reevaluate that plan and really figure out why we didn't get the results that we wanted to get. So whether you're felling a tree for cleanup, firewood, or for lumber, you want to make sure that you minimize the amount of pull and split at the hinge. That means your complete plan needs to really observe the leans of the tree, side to side, forward to back. If you do that, you're able to pick a tool out of that toolbox that's going to be able to give the proper release and limits the amount of loss of control and pulled fiber or split that can take place in the tree. So I appreciate you taking a look. Hopefully you picked up something. Leave us a comment. Let us know what you think. I know there's a lot of different experiences out there, and there's a lot of different ways to look at it. But the basics are the same. Tree fiber, no matter what species, is strong. It can pull, it can split. It's up to us as the operator to have the proper plan on what we need, how to execute that plan to get down to where we have a proper hinge and a proper face notch to reduce splitting and loss of control, pulled fiber, cracking of lumber, all of that kind of thing, so that then we can be able to work safer out there. There's not a tree out there that you can't in 30 seconds really put together a plan of what you can do on that tree. If you plan to cut it from the ground, definitely it's 30 seconds. It's going to take a little longer if your plan shows that you need to have the top taken out or removed, or you have situations of damage on the trunk or the fiber. That all comes into another variation of the plan. But in most all situations, in 30 seconds, you can know whether you can do it and succeed, or you've got to go to a more intensive plan, a plan B. So thanks for dropping by. We hope to see you along the Forest Apps Road sometime in the near future. And we wish you good sawing.